Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, you are lying still now, and in this stillness, something is happening, quietly, invisibly, inside you, beneath the soft rise and fall of your chest, beneath the cushion of skin, tissue, bone. Your brain is not resting. It is listening, adapting, reshaping itself in silence. You may think of your brain as fixed, as something shaped long ago and mostly unchanging now, but that is only a shadow of the truth. Your brain is not a statue, it is a river. And even as you close your eyes, even as the world slows around you, this river flows. Neuroplasticity, a word that sounds complex, clinical, but what it really means is gentle, a kind of forgiveness written into the body, the ability to change, to learn, to grow, to recover, to rewire, to find new paths when the old ones are lost or broken. And this isn't something rare, happening all the time, every time you learn something new, every time you form a memory, every time you choose differently, feel something deeply, or even imagine a new possibility. Your brain responds. It is sculpted by the rhythm of your days, by what you do, and just as importantly, by what you don't do. It's not a blueprint, it's not a machine. It's more like clay, soft, sensitive, and always listening for what to become next. Think of it, your thoughts, emotions, and habits don't just drift away like smoke. They settle in, they alter the terrain, they trace new lines on the map of your mind. Imagine a path through a grassy field. It's the first time you walk it, the grass springs back. But if you walk it again and again and again, the trail begins to stay. The grass bends, then parts, then disappears. The path becomes easier to walk, faster, automatic. Your brain works like that. With each repeated choice, it wears a groove, not in grass, but in connections between neurons. Synapses fire, chemicals transmit, axons strengthen, pathways form. And the beauty of this is that the trail can change. Old paths, if left alone, begin to fade. And new ones, with practice and attention, can take their place, even after injury, even after long neglect. This is why someone who's lost the ability to speak can, over time, relearn it, not by repairing what's broken, but by building a new route around it. This is why habits form, why recovery is possible, by learning. A language, even later in life, is not just a stretch of memory, but a reshaping of brain tissue. This is why meditation can calm an anxious mind, not by erasing worry, but by gently reinforcing the neural circuits that hold stillness and attention. Plasticity. It's not dramatic. It doesn't shout. It whispers, slowly, patiently, and it begins with what you focus on. Right now, your focus is soft, resting on these words. Your breath, perhaps, has slowed. And in that slowing, in that gentle awareness, your brain is paying attention. This moment becomes part of the riverbed, a small ripple added to its shape. Your brain is always watching what you give weight to. If you give weight to worry, that becomes your practiced route. If you give weight to presence, to breath, to calm those paths, deepen instead. It is not willpower, it is not force. It is direction, repetition, and kindness. Even now, as you lie here, your brain is pruning, letting go of connections it no longer needs, reinforcing the ones it does. Like a gardener, it trims and shapes and prepares new growth. And what does it grow toward? Toward meaning, toward attention, toward safety, if you give it safety, toward healing, if you give it time. There was once a time when scientists believed the adult brain was static, that only in childhood could new neurons form, only in youth could change occur. But that belief was wrong. It was like thinking a forest could grow only in spring. We now know the brain is alive with possibility, even in late age, in darkness, in illness, in recovery, in grief. It is listening, always listening, for the signals you send. What signals do you send with your habits, with your thoughts, with your expectations? Do you tell your brain the world is dangerous? Or do you tell it there is space to rest? Do you tell it that you are stuck? Or do you show it gently that change is possible? It believes you. Whatever you repeat, your brain learns to expect. So if you speak softly to yourself often enough, your brain will begin to build pathways of softness. If you allow small moments of peace regularly enough, it will carve room for peace. This isn't magic, it's biology. But it feels like hope, and hope too is a pattern, one that can be practiced, one that can be learned. Let's pause here. Feel your body as it lies on the bed or the chair or the floor. Let your shoulders drop, let your face soften. Notice your breath, not as a task, but as a sensation. Something quiet, something simple, something real your brain is noticing, too. And as it notices, it shifts. Connections adjust, chemicals release, networks realign, ever so slightly. This is neuroplasticity, not an event, but a process. Not a technique, but a truth. Your mind is not a finished sculpture. It is a tide, and the tide moves in response to the moon of your attention. Where you focus, often, with care becomes who you are, or at least who you are becoming. Even memories change over time. Not in their facts, but in their contours, like stones rubbed smooth by the river. What you remember is filtered through what you feel now, through the person your brain has become. Since this is why healing old wounds can happen in the present. Because how you feel today affects how those wounds are held, or softened, or slowly redefined. Your brain doesn't forget pain, but it can learn to hold pain differently, to wrap it in different circuits, to reshape its meaning. And meaning is powerful. Meaning tells the brain where to invest energy, where to grow, what to reinforce. So give it good meaning, gentle meaning, rooted in breath, in connection, in care. Even if you've been hurt, even if you've made mistakes, especially then, because neuroplasticity is not only the science of learning, it is the science of forgiveness, the evidence that nothing is fixed, that what was does not have to be what will be. Your habits can change, your reactions can change, your identity, the story you tell yourself about who you are, can change, not overnight, not by force, but through kindness, through repetition, through believing that your brain is not finished. It is only beginning again, and again, and again, with every sunrise, with every breath, with every moment you choose differently. So, tonight, as you rest, as your muscles grow heavy and your thoughts drift, remember this: even in sleep, your brain is changing. Rest is not the absence of progress. It is one of its deepest forms. During sleep, memories consolidate, neural networks clean house, synapses strengthen. You may feel still, but inside, your brain is growing. So give it something soft to grow toward. Give it a night full of breath, of peace, of safety. And tomorrow, just maybe, it will wake shaped slightly different, slightly more ready, slightly more kind. Because even in darkness, your brain listens for light, for light. You think thousands of thoughts each day. Most come and go, like clouds that pass across a slow sky, unnoticed, unlabeled, unremembered. But not all of them vanish. Some return, some deepen, and some leave behind a trail. Your thoughts are not ghosts, they are real, physical events inside your brain. Each one is a movement, electrical, chemical, alive, like tiny flashes across the vast, dark surface of a lake. They ripple through neural tissue, lighting up regions, activating networks, stirring memories, triggering emotions. And these flashes matter. They don't just flicker and fade. They shape each thought, whether hopeful or fearful, joyful or bitter, gently nudges the architecture of your mind, not drastically, not all at once, but softly, repeatedly, and over time, like water on stone. That repetition matters. Picture your mind as a soft field of new snow. It's the first time a thought passes through. It leaves a faint trace, barely visible. But if the same thought returns, again and again, it deepens. A narrow path becomes a clear trail. A trail becomes a groove. A groove becomes a rut. And so, without realizing it, your most frequent thoughts begin to shape the default terrain of your inner life. This is not just poetry, it's neuroscience. The brain works through efficiency. It strengthens the connections you use most often. It's neurons that fire together, wired together. It's an old saying in science, but it remains true. So, if a thought, I'm not good enough, or I can't, or I'm always behind, repeats often, your brain adapts. It makes that thought easier to access, faster to find. It's more automatic, not because it's true, but because it's practiced. Likewise, if a thought of calm, this breath is enough, or I am safe right now, or I can try again tomorrow, becomes familiar, your brain supports that too. Every thought is a footprint, and footprints, over time, become pathways. This is how habits of thought form, not in one dramatic moment, but in hundreds of quiet steps. And with enough repetition, even the harshest inner voices can begin to feel like facts. But they are not facts. They are grooves. And grooves can be softened, rewritten, rerouted. That is the invitation of this chapter, not to control every thought, but to become aware of their echoes, To notice which ones return again and again, And to gently ask, is this the path I want to deepen? You don't need to fight your thoughts. Fighting them only gives them weight. Instead, you can observe. You can become curious. And when needed, you can choose again. There is a practice called noting in mindfulness, the simple act of silently labeling what arises in the mind. When a thought appears, worry or regret or planning, you just note it, not with judgment, but with acknowledgement. You see it, say hello, and you let it move on. This simple act, practiced gently over time, begins to break the automatic grip of old patterns. Because when you name a thought, you are no longer inside it. You are beside it. And that tiny shift from identification to observation is the beginning of freedom. Imagine walking a familiar trail through a forest. You've walked it so often, you know every turn. But one day, you pause. You look around. You notice, just to the side, a faint opening in the trees. It's a new direction. It's unmarked. Maybe a little uncertain, but it's there. That moment of noticing, of stepping off the well-worn path, is the same moment that begins change in the brain. You don't need to erase the old trail. You simply need to walk a new one often enough that it begins to appear. That is neuroplasticity. That is how thoughts leave footprints. Gently can be redirected. Let's take a breath here. Breathe in slowly, deeply. Let the air expand in your belly. Hold it, even slower than you breathed in. Let your shoulders soften. You may not feel it, but in this stillness, your brain is learning. 8. It is listening. It is reshaping itself around your attention. If you breathe this way often, if you speak to yourself gently, if you practice presence, even for a few moments each day, those become your new footprints. And they matter because the landscape of the brain is not fixed. It is a living map, terrain that responds to where you walk most often. Even pain leaves its footprints, trauma, grief, shame. These are not just emotions, they are events etched into neural pathways. But healing is also an event. So is kindness. So is safety. Every small moment of self-compassion begins to redraw the map, even if the pain doesn't disappear. It can be held differently, with more space, with more breath, with more softness around its edges. This is not easy, but it is possible, and it doesn't happen through willpower. It happens through practice, tiny repetitions, small kindnesses, choosing again and again and again. You are not your thoughts. You are not your grooves. You are not the well-worn paths that pain has carved through you. You are the walker. You are the one who notices. You are the one who pauses. You are the one who tonight chose to lie here and listen, even if only for a few moments, to something slower, something different, something true that matters. That is a footprint too. And if you return to this place, this breath, this noticing, this softness, even just once more tomorrow, that return will deepen the trail. And over time, it becomes easier to find, easier to walk, easier to trust. Let your thoughts drift now. You don't need to hold them. You don't need to stop them, okay? They can come and go like waves, like wind across a tall field, like leaves that pass above you as you lie on the earth. Below and beneath those leaves, in the quiet soil of your brain, new roots are forming. The roots of different habits, of different thoughts, of different feelings about who you are and what is possible. Not because you forced anything, but because you noticed. You stepped aside. You allowed new ground to soften. That's all it takes. The brain does the rest. Footprints don't need to be loud. They just need to be consistent, gentle, kind. You don't just see the world, you sculpt it with your attention. Even now, lying still, your body resting, your eyes perhaps closed, something inside you is choosing what to notice. A thought, a sound, a feeling in the chest, a memory, a flicker of worry, a moment of calm, whatever rises to the surface of your mind that is not random. It's shaped by where your attention rests. Attention is not simply noticing. It is a quiet act of creation, like the hands of a potter shaping clay on a wheel. Attention presses gently into your inner world, okay? And what you attend to begins to take form in your brain. Attention isn't one single thing, okay? It's a chorus of processes, visual, auditory, emotional, intentional, all working together to filter experience. Because the truth is, the world offers far more information than you can process at once. And so your brain must decide, out of all the noise, what should it listen to? Out of all the light, what should it see? Out of all the thoughts, which ones should it amplify? That's attention, not just observation, but selection. Not just noticing, but highlighting. And in doing so, it gives shape to reality. When you focus on a memory, the neural circuits involved in that memory light up again. When you focus on a sound, the hum of a fan, the rhythm of breath, your auditory system tunes itself, becomes more sensitive. When you focus on your breath, the body shifts, heart rate slows, stress hormones reduce, muscles soften. Attention is not separate from the body. It is woven into it. And where your attention goes, your biology follows. There's a well-known experiment in psychology. Participants are shown a video where two teams pass a basketball back and forth. One team wears white, the other black. The participants are asked to count how many times the white team passes the ball, and most do so. They count carefully. They concentrate. But when the video ends, the researchers ask, "Did you notice the person in the gorilla costume who walked through the middle of the game?" Many do not. They are stunned. They watch again. And there it is, a full-size gorilla, walking slowly, even beating its chest. How could they miss it? Because attention narrows. Because when the mind focuses on one thing, it filters out others, not out of failure, but out of design. This is called inattentional blindness, a reminder that attention is both a spotlight and a shadow maker. What you see clearly depends on what you're not looking at, okay? And this has implications far beyond psychology labs. It means that what you attend to most in daily life, that's what feels most real. If you constantly scan for mistakes, for threats, for failure, your world begins to reflect those shapes. Not because that's all there is, but because that's what your attention has been trained to highlight. Likewise, when you begin to focus on calm, on breath, on the feeling of support beneath your body, you begin to tune into something else. And that something else grows. This is not fantasy. This is neurobiology. Attention changes how the brain wires itself through a process called experience-dependent plasticity. Your focus strengthens certain pathways while letting others fade. Use it, and it grows. Ignore it, and it thins. Your attention is a sculptor, and the sculpture is you. But here's the quiet grace in this process. You can guide it, not perfectly, not always easily, okay? But you can choose again and again where to place your gaze. Let's try that now. Bring your awareness to the space around your body. Not your body itself, but the air just outside of it. It's a quiet envelope of space in which you lie. What does it feel like to attend to that? Now shift. Notice the weight of your head. Where it touches the pillow, the softness, the gravity down, your breath, noticing, not changing, just the natural rise and fall. Each shift in attention is a brushstroke. It's a subtle redirection of inner resources. It's a decision about what matters, even if only for a moment, and moment by moment, that matters. Deeply in mindfulness practice. Attention is often described as a flashlight. You hold it gently, you point it, you notice what it reveals, okay? And when the beam begins to drift, as it always does, you bring it back, not with force, not with judgment, it's return. The art is not in staying perfectly focused, it's in returning over and over without anger. Each return is like lifting a small weight, strengthening the muscles of awareness, softening the grooves of distraction, lighting new paths in the mind. And over time, the places you return to, those become your home. So if you often return to worry, worry becomes familiar. If you often return to resentment, that emotion grows more accessible, aloof. But if you begin, slowly, gently, to return to breath, to calm, to the sensation of simply being alive, then those become more accessible too. The sculptor does not need to hurry. Stone is not shaped in one day. Neither is a habit of mind. But with steady hands, with slow tools, something beautiful emerges. You may wonder, what about unwanted thoughts? Intrusive worries, old memories that barge in uninvited. Here too, attention is key, because resisting these thoughts only feeds them, but observing them, noticing their shape, then gently placing your attention elsewhere begins to soften their grip. You are not ignoring, you are choosing. Like letting a leaf float past in a stream without grabbing it, and the stream continues. Hey, and your mind becomes more spacious. There's a phrase in neuroscience, top-down regulation. Hey, it means the higher parts of your brain, the ones involved in awareness and choice, can influence the deeper, older regions that govern emotion and impulse. But only if you pause, only if you notice, only if you bring light to the darker corners. And attention is that light. A single beam of quiet focus can calm the storm. It can slow the racing pulse. It can bring you back to now, because now is the only place attention lives. The past is memory. The future is imagination. But this breath, this feeling of air entering the nose, leaving through the lips, this is real, and it is enough. In meditation, people often struggle to clear the mind. But the goal is not silence. The goal is presence. Letting the mind do what it does, but choosing again and again to place your awareness gently on something steady. It could be breath, sound, a visual image, a single word. That steady point becomes an anchor, not to trap you, but to hold you, to remind you that you can choose where to look, and the more you look, the more you see. It's not just outside, but within, because the true gift of attention is not what it reveals in the world, it's what it reveals in you. The ability to focus is also the ability to listen, to sense what matters, to recognize what is real, to let the noise fall away. In a world that constantly demands your gaze, that flashes, scrolls, beeps, vibrates, choosing to attend slowly, deliberately is a radical act, a return to something quiet, something human, something whole. And perhaps this is the great secret of attention. It doesn't just shape your thoughts, it shapes your identity. It shapes your reality. It shapes your experience of time, because when you attend closely, time slows. Moments stretch, details bloom. The mind stops running ahead. You arrive, finally, not at a destination, but at a state of being, right here, right now, with breath, with awareness, with softness, and from this place, you can choose your next step. You imagine falling as a simple thing, a dropped stone, a leaf spiraling downward, a human figure, arms flailing slightly, pulled toward the earth. But this is only how it appears. A trick of vision. Underneath, something more intricate is unfolding. Something deeper than movement. Something quieter than force. Because in the language of physics, falling is not a motion through space. It is a motion through space-time. That makes all the difference. Let's begin slowly. Imagine you're floating in deep space, far from planets, far from stars. You're utterly still. No gravity tugs at your feet. There's no up, no down. But then, ahead of you, something massive begins to appear. A planet, a star, a black hole. It doesn't pull you like a string, curves the space-time beneath you. And you, still following the straightest possible line through space-time, begin to drift. Not because you're being pulled, but because the straightest line is no longer straight. This is the insight Einstein gave us in 1915 with his general theory of relativity, that gravity isn't really a force. It's a change in the shape of the stage. The Earth orbits the sun, not because it's being yanked around by an invisible tether, but because it's rolling along a curve in space-time, a curve carved out by the sun's mass, and you fall toward the Earth, not because the planet grabs you, but because the floor beneath you is bending downward. You're following the shape of time itself. We call this geodesic motion. It means the path of least resistance, the natural line. When astronauts float inside the International Space Station, they're not escaping gravity, they're falling with it continuously. Their orbit is a kind of never-ending fall. They fall around the Earth, not into it. And if you could ask them what they feel, they'd say, nothing. That's the beautiful paradox of free fall. The closer you get to gravity's true nature, the less you feel it. You become weightless, not by escaping gravity, but by surrendering completely to its curve. This is why Einstein said, a person in free fall is the only one truly at rest, because they are not resisting the shape of space-time. They are moving through it perfectly. Let that thought settle for a moment, because it changes how we think of falling, not as failure, not as danger, but as participation in something vast, and curved, and natural, a surrender to the deeper geometry of the universe. Now, consider something more extreme, a black hole. This is gravity pushed to its limits, a place where space-time curves so steeply, even light cannot climb out, a place where falling becomes permanent. If you were to drift too close, you would cross what physicists call the event horizon, the point of no return. From the outside, your fall would appear too slow. Time would stretch, your movements would seem frozen, smeared out in strange slow motion. But from your point of view, you would fall. You would pass the threshold without drama. You would descend into darkness, not because something pulled you, but because the path forward the path through time itself. Curved inward, you followed it. This is perhaps the most poetic truth hidden inside modern physics. To fall is to follow the curve of time, and in a curved universe, even time is not steady. It stretches near mass, slows near gravity. Clocks on satellites tick faster than those on Earth. Clocks near a mountain summit run differently than those in a valley. Your heartbeat, your perception, all slightly shaped by where you fall in spatrodite. You are not separate from the curve. You are living inside it. And every time you walk downhill, every time you drop your keys, every time you drift off to sleep and feel yourself slipping, you are, in a small and faithful way, tracing the shape of the cosmos. Even your dreams bend inside it. Think of this. When you stand on Earth, you're not pushing down on solid ground. You are leaning against a bowl carved by mass. Your body resists the inward slide. Your bones hold you up. But the moment you stop, the moment you let go, you fall. And falling is not failure. It's honesty. It is the most natural thing your body can do in a curved world. Falling is how the universe says, you are part of this geometry. You are not outside it. You do not float above the rules. You are made of the same stuff as stars, and you followed the same curves. Even the light from distant galaxies follows those bends. Gravity is so strong, not because it pulls, but because it whispers to everything, this way. This is the shape of time. That's why black holes can lens light, bending it around them like glass. That's why galaxies spiral the way they do. That's why Earth's orbit is not a perfect circle, but a loop carved by motion through a flexible stage. The deeper we look into the sky, the more we see these curves. Light bent, time stretched, matter falling, not just in space, but into time. And you, too, fall through time, second by second, minute by minute. But it's not passive. It's not empty. You are part of a dance choreographed by invisible curves. Each breath is a step, each thought a ripple, and slowly the path you trace becomes part of the pattern. In modern physics, we no longer see the universe as a fixed grid, but as a soft, woven fabric, and you are a thread inside it. When you sleep, you still fall. When you dream, you still fall. But it is not a drop. It is a glide, smooth movement through the tilted hourglass of existence. You might ask, if space-time can curve, can it break? Yes and no. It can tear at singularities. It can stretch endlessly in expanding universes. It can ripple, like when two black holes collide and send out gravitational waves. We've detected these waves now. We've heard the universe ring like a drum stretched over billions of miles. And each wave was born from a fall, from something massive collapsing inward. From the curve deepening, tightening, turning into sound. The song of space-time, a lullaby in gravity. So tonight, as you rest, know that your body is resting not on a bed, not on the floor, but in a bowl of space-time, a cradle of curvature. The earth spins, the moon tugs. The sun holds all of it in its curve, and you fall softly into that shape, every breath a slide, every moment a drift, every memory an orbit through an invisible geometry. And when you wake, you will still be falling, still bending time with your mass, still tracing the lines of the world's quiet fabric, because you are not separate from the cosmos. You are a wrinkle in its cloth, a dancer in its curve. A witness to its softness. To fall is to trust that the universe holds shape and that you belong inside it. You live in a world touched by one man's strange, tender thought. He did not shout. He didn't storm podiums or wear medals on his chest. He walked slowly, thought slowly, wrote carefully, and with a few pages, he changed the direction of human. Knowing his name was Albert Einstein, but not the Einstein you imagine from posters, wild hair, its tongue out, caught in the carnival of late fame. No, the real Einstein of this story is soft and quiet. A 26-year-old clerk in a patent office in Bern, Switzerland, sorting through inventions all day, thinking alone at night. In 1905, he wrote 4 papers, each a pebble dropped into the still pond of science. But one of them bent time itself. Special relativity. It didn't look like a revolution. There was no explosion, no war, no invention of fire or wheel. But the world had tilted. Einstein said something simple. Yet world shifting, the laws of physics are the same for all observers in uniform motion. And more provocatively, the speed of light is constant for all observers, no matter their motion. This broke something deep, because before Einstein, time was time, ticking everywhere, ticking the same. It was a river that flowed forward at one speed, but Einstein said, not so. He saw time as more like taffy, soft, stretchable, dependent on motion. He said that if you move faster, time slows down for you. Not as an illusion, not as a metaphor, but truly, physically. Your seconds lengthen, your heart beats slower, your aging softens, and it all came from holding one truth firm. That light is traveling at 299,792 kilometers per second, always moves at the same speed, no matter who you are, where you are, or how fast you're going. Imagine that. You shine a flashlight while standing still, and again while racing in a spaceship at unimaginable speeds, and the beam always moves away from you at the same pace. To keep that true, the universe must bend time, bend space. It must adjust itself delicately, invisibly, to preserve this one sacred speed. That's the heart of Einstein's gentle revolution. A clock on a moving train runs slower than a clock on the platform. And not just in storybooks or dreams. We've tested it with planes, with satellites, with particles hurled around giant rings. It is always true, because the universe bends to protect its rhythm. And that rhythm is set by light. Think of it like this. You're inside a spaceship. A beam of light bounces between 2 mirrors. If you're still, the light goes up and down, a perfect vertical tick. Now, imagine the ship begins to move sideways. Someone watching from outside. The light now takes a diagonal path, like a triangle, longer, slanted, but the speed of light stays the same. So, how does the light still reach the mirror at the right time? Only if time itself stretches. Only if the clock on the moving ship ticks more slowly. That is the logic. That is the poetry. Motion changes time. Einstein didn't build a new clock. He revealed the secret the old one had hidden. And all of this came not from fancy tools or giant labs. It came from sitting still, thinking quietly, following logic to its soft conclusion. This is why we call it a revolution, but one written in candlelight. It's not gunpowder. Let's walk deeper. Special relativity has 2 main ideas. First, the laws of physics are the same for all non-accelerating observers, meaning whether you are on a smooth train or sitting in your chair, the universe behaves consistently. Second, the speed of light in a vacuum is the same for everyone, meaning light is the heartbeat of physics, the metronome that never falters. But if that's true, then things must shift to make it so. Time must dilate, lengths must contract, mass must grow. All of this just to keep light steady. It sounds strange, but reality agreed. Later, Einstein would extend these ideas to acceleration and gravity, giving us general relativity, a theory that wrapped everything in curvature. But even here, in the early softness of special relativity, something profound had taken root. That time is not universal, it is local, and that space is not flat, okay? It is stitched to time. Together, they form spacetime, not 2 things, but one cloth, and you move through it every moment, even when you are still. Especially then do. You feel it? The room around you, calm and quiet, holding more than air. It's holding the shape of your life, your velocity, your now. You are not outside of Einstein's dream. You are inside it. Your phone's GPS works because it adjusts for time dilation. Your atoms behave because energy and mass are linked. E equals mc, a formula whispered into history by that same young man at the patent office. Let's pause on that. E equals mc squared. It means energy equals mass times the speed of light squared. It means mass can become energy. It means a tiny amount of matter holds an ocean of light. It means that every cell in your body is not only mass, it is potential. It is waiting. It is light in disguise. All of it, the ticking of time, the bending of speed, the shape of mass comes from this gentle shift in how we think. Einstein didn't shout. He whispered, and the universe bent to listen. Imagine how lonely that must have felt at first. In 1905, most people didn't understand him. Even great scientists were puzzled, resistant. But truth is patient, and over time, experiment after experiment confirmed it. More particles falling through Earth's atmosphere, living longer than they should because they're moving fast. Jets flying around the world, showing clocks returning slightly younger. Atomic clocks ticking with precision, proving relativity over and over again. The world caught up, slowly, and Einstein, who once worked in silence, became a symbol, not of wild genius, but of patient thought. He showed that truth can arrive softly, that the universe is not made of rigid rules, but of curves and adjustments, and small, delicate corrections to preserve deep symmetry. Relativity is not chaos. It is grace. When you lie down and close your eyes, you are not separate from this. You are floating through curved space-time. Your body, your dreams, your heartbeats, all part of a quiet, relativistic ballet. Your seconds are not identical to those across the room, not perfectly, because motion changes time, mass changes time, and you are made of both. So when you feel the softness of sleep approach, think of Einstein. Think of the young man who dared to ask, what if time bends? And remember that you, too, live inside that answer. High above your head, at this very moment, machines are floating through slow time. You don't see them, you don't hear them, but they are there, circling the planet in gentle arcs, looping endlessly in the quiet dark. They are GPS satellites, and they are not just moving, they are drifting through a slightly different now. Each one holds a clock. It's not a clock with hands and ticking gears, but an atomic clock, precise, steady, unimaginably regular, a heartbeat made from cesium atoms, pulsing in perfect time. But that time is slower than yours, by a fraction, by a whisper. And yet, it matters. Without accounting for that slow drift, your phone would think you're somewhere else. 100 meters off, a mile away, lost, because time, not just signals or coordinates, is what GPS is built upon. To find your location, your device listens to signals from several satellites. Okay, each signal says, I was here, at this time. Your phone receives them all, compares the times, okay, and calculates where you are. But if the satellite clocks are drifting, if time runs slower up there, then your phone would be tricked, unless it already knows, unless someone already told it. Time bends with motion. Time bends with gravity. And someone did. Einstein did, in the calm revolution of relativity. He showed two things that matter here. First, special relativity tells us that because satellites are moving very fast, their clocks tick slower compared to yours on Earth. Second, general relativity tells us that because they're also higher up, farther from Earth's gravity, their clocks tick faster than those deep in the gravitational weld. So, two effects pull in opposite directions. Speed slows time down. Altitude speeds time up. Which one wins? It turns out, the altitude wins more. A GPS satellite orbits at about 20,200 kilometers above Earth. There, gravity is weaker. That means time runs faster, by about 45 microseconds per day, but the speed, about 14,000 kilometers per hour, slows time down by about 7 microseconds per day. Net result: a satellite's clock ticks 38 microseconds faster per day than yours. On the ground, it doesn't sound like much, but your phone's GPS depends on nanoseconds. Even a millionth of a second of error can throw off your position by hundreds of meters. So scientists quietly, calmly adjust. They build the satellites with preloaded clocks so that once in orbit, they sync perfectly. That's right, every GPS satellite is launched with a clock deliberately ticking slowly, so that after relativity stretches it in orbit, it becomes just right. It's like baking a cake at sea level that tastes perfect at altitude. That's how intimate our relationship. What Einstein has become, his thoughts now live in our pockets. In every step you take with your map open, okay? In every turn your car makes with satellite guidance. You don't feel the corrections. You don't see the curved spacetime, but your location, your directions, your sense of where it all leans quietly on bent time. Let's pause, okay, and look up. Imagine one of those satellites, a metallic body with gold foil panels, spinning slowly in the blackness, solar wings outstretched, absorbing the cold sunlight, its instruments humming gently in the vacuum inside. The atomic clock pulses. Cesium atoms vibrate exactly 9,192,631,770 times per second. That's what defines a second. But that second, up there, is not quite yours because of speed, because of gravity, because of relativity. Einstein's equations are not theories to this machine. They are reality. They are architecture. Every GPS calculation, every pin you drop on a digital map includes corrections for time dilation. Every route you trace is quietly traced through the folds of curved time, even now. As you read this, there are 31 satellites in the US GPS constellation, each one broadcasting time, and not just the time, but where it was at that time. Your phone is an interpreter, constantly solving the puzzle. This signal came from there, at that moment. That one came from over there, a bit later. Can't. From that tangle, it locates you. It's as if 4 or 5 voices whisper your position to you at once, okay? But those voices are singing from slower time. To hear them clearly, you must translate. And this translation, this relativistic correction, is baked into every GPS chip. You use relativity every day, not just in science fiction, not just in textbooks, but in every Uber, every hike, every pizza delivery, because time doesn't behave. And so we must adjust our tools to the true rhythm of the cosmos. We must build with Einstein in mind, and we have. It's quiet engineering, sleepy physics. It's bedtime logic, but it's real. Now, let's go deeper. The GPS system must also account for another challenge. Earth's shape. Our planet is not a perfect sphere. It bulges at the equator, flattens at the poles, and gravity, which shapes time, is not perfectly even, so the system must also adjust for tiny variations in gravity across the globe. Different locations on Earth feel time ever so slightly differently in high-altitude places. Time runs faster. In deep valleys, time slows down. Your position is a poem of time curves, and that means so is your life, because time dilation doesn't just affect satellites, it affects you. If you lived your whole life on top of Mount Everest, you would age just a little faster than your twin at sea level. Not by days, not by minutes, but by milliseconds, stretched over decades. Still, the principle holds. Your altitude, your motion, your location, all shape how your time flows. Einstein turned time from a metronome to a tapestry, and satellites trace that tapestry. Every day, in their motion, we glimpse time's softness. In their delay, we see precision's cost, and in their corrections, we find faith that the universe behaves, and that we can learn how. So the next time your phone finds your place on Earth, remember, it did so through a ballet of light speed signals, adjusted for relativistic bends. It's translated from distant clocks, drifting softly through space. You are here because someone, long ago, listened to Einstein, and now you drift too. Even as you sleep, the Earth rotates beneath the stars. You are moving at 1,000 miles per hour just by standing still, and your seconds are stretching ever so slightly, just enough to matter, just enough to remind you that time isn't rigid. It is shaped by motion, by altitude, by orbit, by you, by you. Close your eyes and imagine motion, not walking, not running, but drifting forward at impossible speed. You are not bound by roads. You are not slowed by sound. Instead, you are gliding near the edge of light itself. It's not quite there, but so close that the universe itself seems to slow around you. And as your body cuts through the stillness of space, something else changes too. Time, once familiar, begins to shift. Not in chunks, not in leaps, but in smooth, imperceptible stretch. The faster you move, the slower you live. This isn't metaphor. It's the gentle truth of special relativity, Einstein's soft correction to the way we thought the cosmos worked. According to his insight, the speed at which you travel through space changes the speed at which you move through time. Time, as it turns out, is not separate from space. They are woven together into a single fabric, spacetime. And when you move quickly through one, you move slowly through the other. Think of your life as a ribbon being pulled across a table. Okay? If you move the ribbon straight across, it glides easily. Okay? But if you start sliding it at an angle, some of the motion goes sideways. It takes longer to reach the other edge. Speed through space steals speed through time. This is why astronauts on the International Space Station, traveling at over 17,000 miles per hour, age just a little, more slowly than you do here on Earth. It's a tiny effect in low orbit, just a few milliseconds here and there, but it's real, and it's been measured with clocks, light, with trust. Now imagine something greater. Imagine a spaceship built not for orbit, but for velocity. It doesn't circle the Earth. It pierces the dark between stars. Its engines fire not for minutes, but for years, accelerating until it travels at 90% the speed of light. At this speed, time on board flows at half the rate as it does on Earth. You, inside this vessel, still breathe, still blink, but everything beyond your window races forward in time. A year for you is 2 years for the ones left behind. Now, accelerate more to 99% the speed of light. The time stretch grows sharper. Every hour for you is 7 hours on Earth at 99.9%. Time slows so much that one day on your ship equals 20 days for those on Earth. And yet, for you, inside, nothing feels different. Your heartbeat is still yours. Your breath still follows the same rhythm. Time feels normal because, for you, it is. Relativity doesn't break your experience. It repositions it. Others watching from Earth see your movements in slow motion. Your hands rise more slowly. Your voice draws out. Your life, viewed from the outside, becomes soft and extended. But from inside the vessel, from your perspective, you live. You are not frozen. You are not slowed. You are simply moving. This phenomenon is called time dilation, okay? And it is one of the most poetic truths of the universe. Speed dilates time, but only for those in motion. It is a personal experience, subjective yet universal. Let's pause now, float here with the thought. If time can stretch this way, is there a limit? Yes, the limit is light. Light always moves at the same speed. 299,792,458 meters per second, no matter who watches it, or from where. This constancy is what led Einstein to his conclusion, to keep light speed the same for everyone. Space and time must adjust. That adjustment is time dilation. It's the universe saying, if you insist on moving quickly through space, I'll let you, but your time must change. And so it does. Even light, the fastest thing we know, pays no penalty. It travels across the cosmos without aging. You could ride a beam of light, you would arrive instantly. From your perspective, no matter the distance, to light, time does not pass. That is not poetry. That is physics. But you are not light. You have mass, and so you cannot reach that ultimate speed. As you approach it, you need more and more energy just to go a little faster, until eventually the energy required becomes infinite. It is a cosmic speed limit, but the dream of near-light travel is not forbidden. And the effects, the time stretching, the slow aging, the bending of seconds, these are real, measured, confirmed. In 1971, scientists flew extremely accurate atomic clocks on jet planes. When the planes landed, the clocks were different than those left on the ground. Not broken, not faulty, just slower. They had drifted gently into a slower now. Later, he placed atomic clocks on satellites, rockets, and space stations. And always, we saw the same story. Time responds to speed. The faster you go, the more time releases its grip. You might wonder, what does this mean for you? You are not a star traveler. You are not an astronaut, but you move. You sit on Earth, which spins at 1,000 miles per hour. That Earth orbits the Sun at 67,000 miles per hour. And the Sun itself drifts through the galaxy at 500,000 miles per hour. You are always in motion, and so your time, even now, is bent. Not enough to notice, but enough to be true. Your seconds are not universal. They are tailored to your speed, your place, your gravity. Time is not a master clock in the sky. It is a quiet agreement between you and the cosmos. Now, imagine a twin. Two of you, born at the same time. One stays, the other travels. They board a ship and sail through space at near light speed. They return years later. For them, perhaps 2 years have passed. For you, maybe 20. The twin paradox, they call it. But it's not a paradox. It's the truth written in the mathematics of spacetime. Time has no favorite pace. It responds to the paths we take. So, what would it feel like to live slower, to stretch your minutes, your heartbeats, your thoughts? Would it feel like floating? Would it feel like a dream? You already know, because sleep is a kind of time dilation. Your body slows, your awareness shifts, and when you wake, the world has changed, ever so slightly. Time moves differently depending on how you move within it. Your memories to dilate. Some days feel short, some moments stretch forever. Time is not only curved by gravity or speed, it is curved by memory, emotion, and perception. The physics remind us, time is flexible. The poetry whispers, so are we. And so tonight, as you lie still, you are moving through space-time, not quickly, not slowly. Truly, your seconds are yours, measured by your motion, softened by your stillness. Somewhere, a particle called a muon travels at near light speed in a lab. It should decay in microseconds. But because it moves so fast, it lives longer, survives, not because of luck, because of time dilation. It moves through slower time, and that extra time is real. It's not illusion, it's not mistake. It is the universe whispering, I bend, I adjust, I honor your speed. And so as you drift further into rest tonight, remember this. Speed is not just motion through space, okay? It is transformation through time. The faster you go, the more softly time holds you, the quieter your seconds become. Time is not a river, not in space. It is a fabric, and gravity is the hand that presses into it. Close your eyes. Imagine placing a marble on a trampoline. It rolls a little, settles. The fabric dips. Now imagine placing something heavier, a bowling ball. The trampoline sinks deeply, curving space beneath the object. That's gravity. And if you were to roll another marble past it, it wouldn't move in a straight line anymore. It would curve around the dent or fall in. This is how planets orbit stars. This is how moons cling to worlds. This is how time, slow and silent, is affected by mass. Time doesn't tick the same everywhere. The stronger the gravity, the slower time moves. A clock on top of a mountain ticks slightly faster than a clock at sea level. Not because it's broken, because it's farther from Earth's core. We've measured it. Atomic clocks, our most precise tools, tick at different rates depending on how close they are to heavy objects. Not much, but enough to be real, enough to matter. Your smartphone's GPS system wouldn't work without accounting for it. Its satellites orbiting Earth feel slightly weaker gravity than we do on the ground. Their clocks tick faster, and engineers had to adjust for that. Just a few billionths of a second per day. But it adds up. Without that correction, your GPS location would drift by miles in a single day. So time is not constant. It's curved. It's personal. It depends on where you are and how heavy the space around you is. Now, go deeper. Imagine standing near a neutron star, the collapsed heart of a giant star. It's small, it'd be 10 miles across, but heavier than our sun. Its gravity is so intense that light bends around it. Its gravity is so intense that time itself nearly halts. For every second you feel, the universe around you ticks forward by hours. A moment by your skin is a lifetime elsewhere. You are not dreaming. This is not science fiction. This is general relativity, the deep poetry of Einstein's equations. Gravity bends space, but it also stretches time. Now, go deeper still. Approach a black hole. Its pull is so strong, even photons, tiny packets of light, cannot escape. Nothing can dot this boundary, the edge of no return. It's called the event horizon. From far away, you could hover above it, just above, not touching. If someone watched you from a distance, they would see your time slow down, your movements slow, your words stretch. You would not notice. Your breath would still be yours. Your thoughts would still flicker at their usual pace, but to the outside world, you were frozen. This is not just a theory. In 2019, took a photo, a real photo, of a black hole's shadow. The Event Horizon Telescope. 8 telescopes working as one. They saw it. The ghost of an event horizon. A dark circle. A missing heartbeat. Surrounded by glowing light. The final screams of matter, spiraling inward. That black hole is in the M87 galaxy. It's 55 million light years away. Yet, there it was. Revealed by patient radio waves. Revealed by the bending of space. In the stillness of time, near a black hole. Time doesn't just slow. It stretches so much that it becomes nearly still. A person falling toward it slowly, silently, would appear to freeze at the edge, forever, hovering, never quite touching, but to that person. The fall continues. Time for them flows normally. They pass the event horizon. They fall deeper, and time outside speeds up until it's unreachable. This idea that time can be stopped, or nearly so, challenges everything we know about clocks, about memory, about now. And yet, it's true. This isn't myth. This isn't magic. This is what happens when you gather enough mass in a small enough space. Time bends. And then it nearly breaks. Black holes are not empty. They are not voids. They are the heaviest things in the universe, collapse to an infinitely small point, a singularity. We don't know what happens there. Physics stutters, equations lose meaning, but we know the effect on time because we can feel it from outside. Time doesn't pass the same for all observers. That idea, so quiet, so strange, is now baked into every satellite, every space probe, every high-speed particle we launch. So let's return back to Earth. You are lying still, but you are not free of gravity. You are deep in its well, pressed gently against the planet's skin. Time is moving a little slower for you than for someone in orbit. It's just a slightly dot, And that difference is part of your experience. Even your dreams are shaped by mass. You are made of atoms that are pulled into gravity's arms. And your seconds, your quiet seconds, are just a little longer than they would be without it. There is beauty in that slowness, in the weight of your moments, in the stretch of your breath. Gravity tugs on time, but it also gives it shape. Without gravity, there would be no orbits, no stars, no galaxies, no planets, no you. Time is bent, okay? But because of that bend, you exist. Because of that bend, light curves and stars shine longer. Because of that bend, matter forms into worlds. Even your memories are curved by the presence of weight. The heavier the emotion, the longer the moment feels. This is the poetry of time. This is the sleep of space, and somewhere far beyond, near a black hole's edge, time is waiting, stretched, quiet, still, waiting for something or someone to fall in. But if time can be bent, stretched, and slowed, can it be reversed? Can you walk backward through a second already lived? Okay. Or must time always move forward, gently and unstoppably, like a tide? You might think time dilation lives only in labs, okay? In rocket ships, in black holes, in thought experiments, okay? But it doesn't. It's already here. In your palm, in your pocket, okay? In the tiny glass rectangle you check when you're lost. When you look for a cafe, you ask for directions home. Your phone's GPS isn't magic. It's a quiet negotiation with orbit above your head. Dozens of satellites orbit Earth. Each carries an atomic clock, pulsing time with extraordinary precision. They circle at about 20,000 kilometers high. Their speed, around 14,000 kilometers per hour. That height means weaker gravity. That speed means motion through spacetime. And both of those, separately, affect time. Each satellite ticks differently than you do, just slightly, but enough to matter. If those satellite clocks weren't adjusted, your phone's GPS would be off by nearly 10 kilometers every single day. You'd get directions to the wrong street. You'd miss your bus. You'd walk in circles. So engineers had to listen to Einstein. They built corrections into the satellites. They adjusted their internal clocks before launch. They rewrote time into the code. It's called relativistic correction. And it happens constantly. Every moment you check your location. Every time your map spins to face north, you're leaning on the fact that time bends. This is not abstract. It's infrastructure. It's baked into the systems you trust. And yet, most people never think of it. Never wonder why GPS works. Never ask why signals from space must be curved before they become helpful. Your phone doesn't tell you about time dilation. It just works, quietly, dependably. But if you pause, if you really pause, you start to see the invisible dance. The GPS system is made of 31 satellites, each one locked in orbit, sending radio waves down to Earth. Your phone listens. It hears several at once. It measures the delay, the time it takes each signal to arrive, and from that delay, it triangulates your position. But for the timing to be accurate, the clocks must be perfect. And to be perfect, they must account for relativity. Speed slows time. Distance from mass speeds it up. At the satellite's altitude, time moves faster by about 45 microseconds per day due to weaker gravity, but also slower by about 7 microseconds per day due to the satellite speed.net effect. The satellite's clock gains about 38 microseconds per day compared to clocks on Earth. That may sound tiny, but for GPS, it's enormous. Light travels 300 meters in a single microsecond. That's 3 football fields. A 38 microsecond error would mean your GPS is off by more than 10 kilometers. Imagine trying to find your way through a city with that much drift. It would be useless. So time dilation isn't a curiosity. It's a correction, calibration. You walk through the world feeling like time is steady, But the truth is, your phone is constantly adjusting, silently reshaping your position based on Einstein's insight. Without general relativity, you couldn't navigate, you couldn't map, you couldn't find the nearest gas station. Einstein lives in your device, in the algorithms, in the adjustments, not as a face on a wall, but as a quiet force behind the scenes. And GPS isn't alone. Communication satellites, weather satellites, military systems, financial trading platforms, all of them rely on clocks. And all of those clocks feel time differently, depending on their speed and position. Every modern system that depends on precise timing must make room for time. Dilation. You live in a relativistic world. You just don't notice. Now, let's drift further. Time dilation also shows up in science labs, in particle accelerators, where subatomic particles are launched near the speed of light. Muons, unstable particles created in the upper atmosphere, decay quickly, too quickly to reach the surface of the Earth, unless they're moving fast. But when they travel at relativistic speeds, their internal clock slows down, and suddenly, they live longer. Long enough to be detected, measured, studied. This isn't theory. This is experiment. Again and again, across decades, we've seen that time is not equal everywhere. It changes with speed. It bends with mass. It must be accounted for. Every jet plane, every high-speed satellite, every system that relies on global timing is an experiment in relativity. But for you, it all just feels smooth. You ask your phone where you are, answers, and you move on. You don't feel the microseconds shift. You don't feel the satellites above. You don't sense the bending of time, but it's there. You are carried by systems that whisper with Einstein's logic, and it goes deeper still. Even your banking system, your internet timestamps, the precise syncing of servers around the globe, all of it relies on timekeeping, okay? And that timekeeping depends on clocks that tick in a relativistic universe. When you send a message, click a button, sign a digital contract, you trust that the clock is correct, that the second on your device matches the second somewhere else. But those seconds are not natural. They are shaped, adjusted. They're cleaned of relativistic dust before they reach your hand. You live inside a story of time that has been filtered for your comfort. And yet, part of you knows that time is not absolute, that seconds drift. Moments can stretch or shrink depending on how and where you are. So now, let's pause. Feel your breath. Notice how it comes and goes like tides on a quiet shore. Somewhere above you, a satellite ticks a little slower. Seconds are stretched. Its heart beats gentler, but its voice still reaches you, and your phone listens. Every moment, you are held in the arms of 100 corrections, all of them rooted in the idea that time is not flat. It is flexible, personal, relative. The next time you check your GPS, know that you are asking the universe for directions in a language where time bends. You are participating in one of the most elegant experiments ever built, not in a lab, but in your pocket. Einstein is with you, not in theory, but in practice, in the background hum of satellite clocks, in the arc of your movement through space, in the soft calibration of your coordinates. You are a creature of curved time. Your tools, quietly, faithfully, keep you centered. But if time can bend and flex and drift, what happens when two people live through different clocks? What if one stays and the other goes far away and returns younger than they should be? You close your eyes and imagine two children, twins, born seconds apart, sharing the same breath, the same hour, the same start. They grow up beside each other. They laugh at the same jokes, sleep in the same room. They are mirrors, reflections of a single beginning. But then one leaves, not emotionally, not metaphorically, physically. A spaceship hums on the edge of morning, and one twin steps aboard, not forever. Just a journey, a round trip through the galaxy, at nearly the speed of light to explore, to test, to feel the stars up close, and the other stays, feet on soil, eyes toward the sky, counting days the way we always have, by sunrises and dinners, birthdays and winters. The spaceship accelerates faster, faster still, until time begins to stretch, not just in feeling. In fact, inside the ship, seconds are lengthened, clocks run slow, heartbeats too, but everything feels normal to the traveler. Because all motion is relative. Inside the ship, a cup of tea cools like always. Dreams unfold at the usual pace. Time feels soft and regular, but only from within. Outside, on Earth, things are different. The twin who stayed sees years go by. Children grow, seasons spin, technology changes, and somewhere across the vacuum, the other twin drifts through gentler time. This is not poetry. This is physics. Time dilation, the kind caused by speed, not just gravity, is not just an idea. It's measurable. Observed, it has been clocked in particles, in satellites, in decaying atoms, zooming near light speed. The faster you move, the slower you age, from the perspective of the one who stays behind. So, when the traveling twin returns, stepping back onto the familiar Earth, they are younger, not metaphorically. Literally, their face is softer, their eyes less wrinkled. Their body has aged fewer years, and the twin who waited is older by decades, if the journey was long enough. They hug, they cry, but something is different. Time, once shared, has split them. This is the twin paradox. Not a trick, not a failure of logic, but a truth of our universe. Special relativity tells us that motion through space-time isn't just about distance, it's about the path you take through time itself. A moving object, especially one moving near the speed of light, takes a shorter journey through time. You could call it a shortcut. But it's more than that. It's a reshaping of how time passes, based on how fast you move. In this story, it matters who accelerates, who turns around. Because the twin on Earth stays in a single frame of reference, but the traveler must speed up, turn, decelerate. These shifts, that feeling of pulling back toward home, they anchor the story in reality. They break the symmetry. It's not just motion that matters, it's change. Acceleration is the signpost that says, this twin experienced something different. And it's true, even today. Astronauts who spend time aboard the International Space Station return just slightly younger than their Earthbound peers. The difference is tiny milliseconds, but it's there. The twin paradox lives in our orbit. Now, expand that thought. What if the trip weren't too low orbit? What to Proxima Centauri? It's a journey at 99.9%. The speed of light could take just a few years on the traveler's clock, but decades on Earth. A child leaves home, returns to find their parents aged into elders, to find cities changed, to find the world older and themselves left behind. Time becomes not just distance, but separation. Einstein once said, the distinction between past, present, and future is only a stubbornly persistent illusion. In the twin paradox, that illusion cracks. The story makes you ache a little, because it is gentle, but profound. What does it mean to grow apart? Not just emotionally, but physically, through time itself. What does it mean to remember someone who doesn't remember the same amount of you? We don't notice these things at earthly speeds. Our cars, our trains, even our planes, they move fast, but not fast enough to make time stretch in ways you can feel. But the universe is bigger than our senses. The laws of relativity don't care what you can detect. They unfold anyway, silently, consistently. The twin paradox is not science fiction. It's science revealed, and its implications are hauntingly real. For deep space travel, for interstellar journeys, for the dream of reaching beyond our solar system. If one day you board a vessel designed to approach the speed of light, you must accept the trade that your time will no longer match the time of those you leave behind, that you may see stars up close and miss entire decades on Earth, that when you return, you'll carry the strange loneliness of having missed what others lived. It's not punishment. It's not error. It's just the way time works when you let it stretch. And yet, perhaps, there's something beautiful here too. That time is not cruel, just quiet, that it holds space for both twins, that it allows such separation, and then gently brings them back together, aging differently, but still together. Maybe we all do this in tiny ways, not with spaceships, but with choices. Some people move fast. They change cities, chase careers, launch projects. Others stay rooted. They build families, plant gardens, count seasons. When they reunite, they've aged differently, not in years, but in rhythm, okay? In what they've seen, and how they've felt time. And yet, they embrace, like twins, still connected, still mirrors the twin paradox. In that sense, isn't just about physics. It's about how life bends us, how time stretches differently for each of us, and still, we find ways to meet again. So tonight, as you lay still, know that time is flowing around you, but also through you. That motion changes it. That gravity changes it. That even dreaming, drifting into sleep, changes the rhythm of your clock. You are part of a bending universe. And you, too, have a twin. The version of you that stayed. The one who aged a little more, or a little less, depending on how you moved and how you dreamed. And perhaps, someday, you'll meet again. But what happens when you don't return? What if you drift far enough, long enough, that even dreams themselves begin to unfold more slowly? What does it feel like to dream on the edge of orbit? You float, not in fantasy, but in the metal stillness of a pressurized chamber. Some 250 miles above the surface of the Earth, the International Space Station orbits. It moves at over 17,000 miles per hour, a streak of human life wrapped in metal and mathematics. Inside, you are tethered only by air, by faith in engineering, and by the quiet ticking of instruments that keep you alive. And yet, you sleep. You curl into a dream, just as you would on Earth, eyes closing, limbs slowly releasing the day's work. But up here, sleep is different, not just in sensation, but in time itself, because time, that ever-present river, does not flow here as it does on Earth. It moves more slowly, not by minutes, not by hours, but by microseconds. And yet, in those slivers of time, dreams begin to stretch. You wouldn't notice at first. You fall asleep like you always have. You close your eyes to the gentle hum of recycled air. You drift with no sense of up or down, only forward. But something is subtly off. Your REM cycles linger. Your dreams, those floating fragments of memory and sensation, seem to unfold with a gentler pace. Not because your mind has changed, but because time itself has. This is gravitational time dilation and velocity time dilation twined together. Like strands of invisible silk, high above Earth, you are farther from the planet's gravitational center. That distance lets time loosen, just slightly, like a shoelace pulled a touch less tight. But you're also moving fast, orbiting the planet every 90 minutes, faster than any car or plane, and speed, as Einstein taught, makes time slow. These two effects, altitude and motion, pull against each other like quiet dancers. Up here, time runs differently. Aboard the ISS, it ticks slower than on the surface below, not by much. Enough that GPS satellites must correct their clocks. Enough that your dreams unfold in a reality that is slightly but measurably younger. It's poetic, but it's proven. Atomic clocks, synchronized and precise, have been placed aboard space shuttles and satellites, only to return home ticking ever so slightly behind their earthbound twins. So when you dream in orbit, you are dreaming in slower time. Your body follows its circadian rhythm, but the clock you measure against Earth's has moved ahead, and so the question arises, what is a dream when it unfolds in a slightly younger universe? Do you feel more rested, more stretched, more detached from the urgency of days? You might, because sleep in orbit has no sunset, no sunrise. The station experiences 16 dawns each day, 16 sunrises, 16 sunsets, light, dark, light again, an endless pulse, but the body adapts. Astronauts wear our masks. They sleep in quiet chambers, okay? They train their minds to rest in a world that never truly sleeps. And within that stillness, they drift, not just through dreams, but through gently stretched seconds. Imagine a memory, a childhood scene, friends laugh, the sound of rain on a window. Now slow it down, just enough that each fragment lasts a moment longer. That's what sleep is like in orbit. Time dilation isn't dramatic up here. Doesn't stop your dreams, but it does tint them, a soft watercolor wash over the canvas of your mind. Your body still rests, your mind still repairs, but it all happens inside, slightly slower frame of reality, and that changes things. Not because the body can feel time dilation, it can't, but because every experience, every moment of rest is built on the foundation of time, and here, that foundation is tilted just enough to notice. Imagine waking up and knowing, absolutely knowing, that the people you love have aged just a little more than you. That your return to Earth will be met with a planet that is inched ahead. Planet whose clocks never paused for you. It's not science fiction. It's your daily truth aboard the ISS. You brush your teeth in slower time. You write emails in slower time. You listen to music, watch Earth spin below, and fall asleep knowing that your seconds are not quite the same as anyone else's. And when you dream, those dreams are made of stretched time too. You float through thoughts, anchored by gravity, untethered by the tick of a wristwatch. Perhaps, in this way, space teaches something that equations cannot. That time is not only measurable, it is malleable. That sleep, that most human act, is not bound by biology alone, but by the physics of the universe itself. And so, you lie there, drifting inside a metal cradle, rocked not by hands, but by motion, by orbit, by the very curvature of spacetime. You think of Earth, of people sleeping far below you, of someone dreaming at the exact same moment, but inside a slightly faster stream of time. They do not feel the difference. Neither do you. But it's there, measured, real. Your dreams are younger. They carry you through a universe that resists sameness, that curves gently around mass, around velocity, around altitude, and you, just by sleeping, are part of that quiet curve. You are living inside a proof, not in a lab, but in a lullaby of orbits and quiet clocks. And when you wake, if you could feel the difference, you might feel time tugging gently at your sleeve, reminding you the universe does not play favorites, but it does play with time. You open your eyes, Earth glows beneath you, and somewhere on its surface, another version of you has already moved on, and yet, you are still you, just slightly out of sync, slightly in orbit. But what if the stretching never stopped? What if time slowed, more and more, until the future could no longer arrive? What happens to a clock when it falls toward a black hole? You are falling, not through air, but through the curve of space-time itself. There is no scream, no wind, no rush of motion, only gravity, only the soft, unfeeling pull of something immense and invisible. A black hole, it does not chase you. It does not roar. It simply exists, quiet, patient, unimaginably dense, and around it, time begins to slow. Not as a metaphor, not as a poetic idea, but as a measurable, physical truth. You fall closer. Behind you, someone watches, perhaps, a friend, or a telescope's lens. To them, you begin to move slowly, too slowly, then nearly not at all. Your image freezes, your limbs locked in stillness, as if caught in amber. But to you, falling, everything feels normal. You do not stop. You continue sinking into gravity's deep well, while the universe above you seems to rush ahead. This is gravitational time dilation at its most extreme. The black hole's mass curves space-time so sharply that time itself becomes a slope, steep, slippery, and eventually nearly vertical as you approach the event horizon. It's the very boundary of the black hole. Something strange happens to time. From the outside, you never seem to cross it. You slow, fade, dim. Your signals stretch, lengthen, redshift into invisibility, as if you are being whispered from a great distance. But to you, within your own frame, you pass the horizon as if through a curtain, soft, silent, instantaneous, and then time stops meaning what it used to, because a black hole does not just trap matter. It traps time. The closer you are to its heart, the singularity, the more time stretches. Seconds become minutes. Minutes become hours, till time, from an outside perspective, seems to pause. This isn't an illusion. It is not science fiction. It is how the universe truly works. Light, which always moves at the same speed, cannot escape. It bends, twists, and finally gives up, not because the black hole is pulling it, but because the fabric of spacetime is simply too steep. Imagine walking on a slope that becomes a cliff and then a wall. Even light, the fastest thing in the universe, cannot climb back out, and you, drifting inward, are now part of a region where time behaves differently for every observer. To the universe, you are frozen. To yourself, you are falling, and no one can agree on what happens next, because what lies beyond the event horizon is not known. Our equations whisper answers, will argue among themselves. Einstein's general relativity says the singularity, the heart of the black hole, contains infinite density. It's a point where the curvature of spacetime becomes infinite. Quantum mechanics, the theory of the very small, refuses to accept this. It calls for something else, something hidden, a deeper truth we don't yet see. Some say the singularity is real. Others say it is a sign that our understanding has reached its limit. But one thing is certain. Time does not flow inside a black hole the way it does elsewhere. It bends, slows, thickens, breaks. It becomes space. Space becomes time. They switch places or blur together into something we no longer have words for. Imagine standing still and watching the universe race forward at infinite speed. Stars form, die, collapse, galaxies collide, new stars rise, all while you drift inward. You could see the heat death of the universe before you reach the center. You could witness time's end before your own breath expires. And yet, to you, inside, there is no spectacle, only silence, only darkness. You are not crushed. You are not torn apart. Not yet. Because the most poetic truth is this: you never feel what the outside sees from Earth. You vanished long ago. From the black hole, you remain forever approaching. Forever, just before arrival. There is no tomorrow for you, and yet, every tomorrow still exists outside your fall. Even time's arrow bends here. Does it move forward? Does it stop? It's time. A direction? Or a temperature? We don't know. All we know is that the deeper you go, the more time stretches. Like dough pulled by gravity, okay? Like a melody drawn into silence. It is called spaghettification, a strange, cruel word for strange, okay? Elegant death. Not because it's violent, but because it is long. Your body, your atoms, feel stronger gravity at your feet than at your head. And so, you are stretched. Not painfully, not even consciously, but relentlessly. You become longer, thinner, a ribbon of memory falling into shadow, and eventually reach a place where no clocks can tick, where no equations can predict, where time has lost all meaning. We call it the singularity, but we do not know what it is. Maybe it is a tear in the universe. Maybe it is a bridge. Maybe it is the beginning of something else, a new universe, a new law, a rebirth. We don't know, because to ask what happens after the singularity is to ask what happens after the end of time, and there is no answer our physics can give. Not yet. We are still learning, still listening for the echoes of black holes. They do speak, you know, not in sound, but in waves, gravitational waves, ripples in space-time itself, released when black holes collide. We felt them. We've recorded their whispers, reaching Earth after billions of years in silence. And in those waves, there is a story of gravity, of motion, of time stretched beyond breaking. You are not the only one who falls. Stars fall, light falls. The universe falls into itself, and the deeper the fall, the slower the story, until it becomes a still image. A moment without end, a clock without hands, a song without sound. And yet, somewhere far away, a clock still ticks. A child runs, a kettle boils, the moon pulls the tides, and time still moves. Because black holes are not endings. They are mysteries, places where time holds its breath. And as you drift, you wonder, not when it will end, but if time was ever truly yours to keep. You close your eyes, if you still have eyes. You think, if thought still lingers, and you wait, not for rescue, not for resolution, but for understanding. For in this darkness, you are not gone. You are simply outside of time, suspended at the edge of forever. But outside the darkness, its life continues on Earth, in orbit, and even in the quiet hum of your phone. What if the device in your pocket has already adapted to time's quiet drift? You don't need to leave Earth to experience time as elastic. You don't need to fall into black hole or board a spaceship or accelerate to near light speeds. You only need to open your phone. There, tucked between icons, behind the lock screen, and beneath the pixels, is a quiet orchestra of clocks. They tick invisibly, soft as breath, waiting to guide you. You've asked for a map, a direction, a point on Earth, and now dozens of satellites, each the size of a refrigerator, reach down from space to help you find your feet. They don't guess. They don't hope. They measure time. You are here on a sidewalk or a hill, on a moving train or drifting through city streets at night, because of the difference between two ticks of two clocks miles apart. Welcome to GPS, the global positioning. The system is not a map. It is not a compass. It is not, really, even about geography. It is about time. Each GPS satellite carries a clock, atomic, precise, unwavering. It sends out a signal. Here is the time. Right now, your phone listens. It hears that time stamp. Dan, it hears another, and another. Triangulating, comparing, calculating, measuring the difference between signals like a conductor sensing rhythm in silence. And with enough time differences, it knows distance. And with enough distances, it knows position. But here's the twist. Each of those clocks up there in orbit is running a little fast, not by much. It's just a few microseconds per day, but enough to make your map wrong by miles, within hours. Why? Because of time dilation. The satellites are moving, and they're high above Earth, which means, by Einstein's theories, they're in a weaker gravity well than you. Time flows differently for them. Gravity affects time. So does velocity. The faster something moves, the slower its clock ticks. That's special relativity. The higher it is in a gravitational field, the faster its clock ticks. That's general relativity. GPS satellites feel both effects. They're moving fast, a about 14,000 kilometers per hour, so that slows their clocks down. But they're also 20,000 kilometers above the Earth, so they experience weaker gravity that makes their clocks tick faster. The net result, their clocks tick faster than yours by about 38 microseconds per day. Tiny, but over time, enormous if left uncorrected. Your location on Earth would drift by 10 kilometers every day. The satellite would think you're somewhere you're not, maybe even in the sea. So every day, every second, your phone corrects for Einstein. It adjusts, it bends time back into shape without you ever noticing. Relativity, the strange warping of time, lives in your pocket. This is no thought experiment. It is your commute, your walk to the coffee shop, your ability to find a trailhead in the mountains. Time dilation isn't rare. It isn't exotic. It's necessary, and we only discovered it by listening to the universe and trusting its silence. For decades, physicists suspected that clocks in different conditions ticked at different speeds, but we couldn't measure it. Not easily. Then came the Half-Keating experiment in 1971. 2 atomic clocks were flown around the world on commercial airliners, one eastward, one westward. They were compared to a clock left stationary on the ground. The results? The flying clocks had experienced time differently. The eastward one, moving with Earth's rotation, was ticking slower. The westward one, against rotation, was ticking faster. Relativity was real, not theory, not philosophy. It's physics. And today, that reality helps you order lunch, navigate traffic, find a lost pet. She could tag a photo. Every one of these is powered by time. Not time as you feel it, but time as it bends, curved, pulled, adjusted. The satellites compensate for this. So does your phone. Engineers bake relativity into the software, not as a curiosity, but as a requirement. Without these corrections, nothing would work. And you, sitting quietly, staring at a glowing map, are participating in one of the most delicate calculations in science. It's humbling to think of the effort behind it. Dozens of satellites, each syncing their clocks, each looping the Earth twice a day. It's each one aging a little differently than you. And still, you find your street, you find the trail, you find home, even when the skies are cloudy, even when you're lost in a forest or in the alleyways of a new city. Your phone still knows because the universe has told it. This bending of time is not fiction. It is not magic. It is the deep structure of reality. A soft reminder that what we call now is a local truth, okay? Not a universal one. If you were standing near a neutron star, your seconds would stretch like taffy. Okay? If you orbited a black hole, you might see the universe's future unfold in hours. But even here, on Earth, it happens. The floor of your house experiences time differently than the ceiling, by nanoseconds. Come, but real, we are all living at slightly different rates, all the time. A mountaintop observatory ages faster than a sea level pier. Not metaphorically, literally. In your GPS, your silent guide knows this. It accounts for, it proves it, and suddenly, the cosmos doesn't feel far away, because part of it is inside your coat pocket, whispering directions. Now you begin to understand just how fragile this harmony is, how perfectly timed the clocks must be, how finely balanced the equations are, how impossibly elegant the math behind. Your morning commute has become, and all of it hinges on a strange truth. Time is not constant. It is not a river. It is not a drumbeat. It is not even fair. It is warped by speed, by mass, by height. And yet, it works because humans, confused, stumbling, clever, have learned to listen, to correct, to adjust, to trust the bending of time, and turn it into a map, a miracle of sorts, not of faith, but of patience, because this map you carry in your hand is also a portal into the deep machinery of the universe. The same principles that govern a black hole also help you find the nearest open bookstore. The same curves that twist the light of galaxies to also help you walk the last few steps to your hotel. What used to be impossible. K. Knowing your exact position on a spinning planet under a vast sky is now ordinary and yet it remains a wonder. You close your map. The phone dims. The screen fades to black, but the satellites remain, singing their silent songs, ticking their lonely ticks, floating above you in a web of time. And tomorrow, when you open the app again, they'll still be there, waiting, correcting, measuring. Time that isn't quite the same as yours, but close enough to know exactly where you are.